Okay, guys, so in this video, we are going to continue our next chapter, which is now going to be probability distribution. So in the last class, we were talking about probability, right? And that was basically most of the probability that I really wanted to get into. There's a lot of probability, but I'm not going to get into a lot of the fancy stuff. So this next chapter, right, is going to be very helpful because it combines a little bit of what we talked about last time in the chapters 1 through 4, and also a little bit of probability. So this is what we call now probability distributions. Okay, so, I forgot the chapter 6. Okay, so this is chapter 6, probability distributions. Okay, so the main thing that you really want to know about this particular chapter is how is data produced? That is basically one of the main things that we really want to know. Okay, so statisticians have always asked this question. So how are we going to go ahead and produce this data? So how do we produce, where does it come from, right? So we saw that we are able to collect data. So if I wanted to find the heights of males, right, then I can probably just go ahead and sample maybe 100 males, take their height, right, record it, and that's how I get it, right? But what statisticians think is that there is some sort of model out there that we can maybe come up with, or we can maybe try to figure out that will make us produce the data and in some way maybe even simulate it too. So what statisticians think, right? Statisticians believe maybe that it is produced by a probability model. Because if you remember, right, if when we were collecting data, some data tend to appear the most, right? So if I were to get the shoe size of all of you guys, then maybe a lot of you guys will make, a lot of the males at least, maybe might be a size 8 or a size 9. Like that's where most of the bulk of the shoe size may be, right? So that means that those appear at a much higher chance than someone who was maybe a size 15 or something, right? I don't know. So what we want to figure out is like, where is this probability model? How can we figure out what this probability model is, right? And that's what probability distribution is. Probability distribution is just a way in which we can just describe data, right? So let me go ahead and define really what a probability distribution is, just so that we can just get on board. So probability distribution is basically this, and I'm going to write it with function, probability distribution function. And I'm going to abbreviate it with PDF because I don't want to be saying that over and over and over again. So this is basically the probability model, right? Our probability model, and when we say by model, I mean like a particular formula, right? Is there a formula that I can think of that when I input, I can input maybe like the height of 63 inches, it will output what are the chances that I'm going to get that probability, right? That's what I want. Is there some sort of function, right? So if you remember, a function is basically something that can pass the vertical line test, blah, 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 whatever. I'm not going to get into that. But basically, PDF is just a tool that helps us by keeping track of outcomes of an experiment and their probabilities. That's basically what it is. Okay, so a probability distribution, probabilities. Okay, a probability distribution is just basically a tool, right, that helps us by keeping track of the outcomes. So what are the outcomes of this experiment and their respective probabilities? So what is the chances that this outcome is going to appear, right? So the way that we usually do it, right, is we use tables, a graph, or a formula, right? So either I give you a legit formula and then you plug it in and it tells you what the probability is going to be. That's what the output is. The graph is just another way that we can describe it, right? A table is probably the easiest way, and that's what we're going to talk about in the very beginning. Okay, so now when I talk about outcomes, right? keeping track of the outcomes, remember that outcomes can either be categorical or they can either be numerical, right? But that's not really what we want to talk about, right? So we can either have numerical or categorical variables, right? But right now what I really want to emphasize is more of the numerical portion, right? Because the categorical variables, right? I mean, yes, we can go ahead and describe them using tables, graphs, and formulas, right? They're just a little bit differently. We have to do something called indicator functions and do other stuff. That's another type of theory stuff. But right now what we really want to talk about is more of the numerical random variables. So, and I said random variables right now. So what exactly is a random variable? Well, a variable itself, you know what a variable is, right? A variable is just a number or a letter that's substituted for a number, right? Like X, Y, Z, right? But a random variable, right, is still the same thing, but the fact that it's random means that it's determined by chance. Okay, so you have a random variable, right, that's just determined by chance. Okay, so there is a particular chance that this particular variable is going to be, so 1, for example. So let's just say X equals 85, where 85 is 85 inches in height, right? Well, X equals 85 inches, right? So what are the chances of this appearing? Well, I don't know. Okay. So we have two different types of random variables. We have discrete and we also have continuous. Okay, we have discrete random variables and continuous random variables. Discrete random variables are variables that you can list or count. So that's what you can do. Those are numbers like -1, 0, 1, 2, 3, right? So things that you can kind of count with your fingers, and all the integers, even though those you can't really count with your fingers, right? So, but all of those are discrete discrete variables, right? Continuous random variables are numbers that cannot be counted. So these are a little harder, right? So yes, you can still plug in these numbers, right? 1, 2, 3. They include these numbers, but they also include like 0.1, 1/2, irrational numbers like square root of 2, pi, e. So all of these numbers, and there's a lot of them, right? So those are what we call continuous random variables. So these two need to be very, very separate because there is going to be a whole theory behind discrete random variables and how we deal with them, and also how we deal with continuous, right? Right now, what we're really going to be dealing with a lot is discrete variables, okay? So something that you can probably do for this to identify whether something is discrete or continuous, right, is do the problem on the PowerPoint that I'm posting on Blackboard, right? So if you go on Blackboard, let me go ahead and escape from this. If you go on Blackboard, you'll see this particular problem, right? So let's do some of them, okay? So let's do part 8, for example. This will help you out differentiating between continuous and discrete. So number of siblings, what would that be? Would that be discrete or would that be continuous? Well, in that case, that would be discrete, right? It will be a discrete random variable because the number of siblings can be 0, 1, 2, or 3. You can't have a 0.1. You can't have a 1/2 of a sibling, right? That doesn't make sense, right? So that's just what that's going to be. What would B be? The number of people passing in a car. Well, that's also discrete, right? Because you cannot have half a person, right? Still, same thing with the number of siblings, right? Part C in this case, weight of a submarine. Well, you can have something that's discrete, like you can have something that's exactly 180 pounds or 1,000 pounds, but in other words, you can't really I mean, even though you can have those whole numbers, right? What you can still have 180.1 or 1,022.7, right? You can still incorporate the decimals, right? So as long as you can incorporate the decimals and the fractions and irrational numbers, then in that case, that's going to make it continuous, right? If you can only if you can think of a counterexample in which you can go ahead and use a decimal, right? Then in that case, the random variable will probably be continuous, right? But other than that, if you have people or animals, something like that, then definitely that's probably going to be discrete. Okay. All right. And part D, the amount of time for the next bus to appear. Well, time is continuous, right? So that will definitely be continuous. Okay. Okay, so I wrote down basically all of the answers right here in my little paper thingy. Okay. All right. Now that I explained what a probability distribution function was, right, we know that it can be between tables, graphs, and formulas. Let's go ahead and try to build a probability distribution. So I don't want to make this video as long as I can, but let's do the next question, PowerPoint number 2. Okay. So what does PowerPoint number 2 tell us to do? Okay. PowerPoint number 2. PowerPoint question number 2. Okay. So this is what we get. Suppose you flip a coin 2 times. Let X be the number of heads that results. Find the probability distribution of this experiment. Okay. So you can go ahead and go on Blackboard and have it side by side. I'm going to go ahead and get rid of this, right? But that's what you want is you want to go ahead and flip this coin 2 times. And I'm going to say X is going to be the number of heads that results. Okay, so, well, let's first figure out what the sample space would look like, right? So I'm flipping the coin twice. Okay, right? So the sample space itself will look something like this. Well, what can I get? I can get a heads, then a heads. I can get a heads, then a tails. Tails, then a heads, and a heads, then heads, right? Oh, sorry. Tails, and a tails. Okay. So so you have 4 options, right? That's what you want. Now, whenever I say find the probability distribution, so find probability distribution. That is sometimes very, very confusing for a lot of students, right? Because the question that I tend to get a lot is like, what the heck does that even mean? Find the probability distribution. Basically, whenever I say that, I say, give me a table, give me a graph, or give me a formula. That's all I'm asking for you. In this case, when you're dealing with discrete types of problems like this, what you might want to go ahead and think about is maybe do a table. A table might be much more easier to do, right? So I told you what the random variable is. Random variables are still going to be variables, right? I said X is going to be number of heads. So how are we going to go ahead and do this? Okay, so I'm going to say X is going to be the first column, right? And my second column is going to be the probability of X, which is number of heads, occurring. Okay, so let's see. So what are all the possibilities? That's where you really have to really think about. Okay, so let's look at, these are all my possibilities. I can have 1 head. I can have 1 heads, right? I can get a 1 head. I can get 2 heads. Can I get 3 heads? No, right? Because there's none of the outcomes. I can get 3 heads. But I can have 0 heads also. So basically, the only possible numbers that I can get is 0, 1, 2. That's all. Those are only the numbers that I can get. Okay? Now, what's going to happen here is I'm going to say, what is the probability of each of them occurring? What's the probability of 0 occurring? 0 heads. Well, that's just 1 out of the possible 4. Because TT here, right? This has no heads, so it's going to be 1 out of 4. Okay, so 1 out of the possible 4 can have 0 heads. What is the probability of getting a 1 heads? Well, that's 2, because you can have the middle, right? So this is just 2 out of 4, which is also equal to 1/2. Okay, what is the probability of getting a 2? Okay, well, that's 1 out of the possible 4. And that's it. That's all it is. That's all that I'm asking for. This is the answer. Now, how do we check our work? Let's add up all of this. So 1/4 plus 1/2 plus 1/4, right? A quarter plus 50 cents plus a quarter is going to give me 1. All probability distributions all probability distributions must add up. I'm going to write add up very loosely to 1. If this is not equal 1, then we did something wrong. Okay, so we need to make sure that everything is add up to 1. Okay, so that is all I'm asking for that in that problem. Don't worry about question number 3 just yet. So just go to the next question. Question number 4. So try question number 4 out. Okay, I'm running out of time, and I don't want to make this video really long, but try to figure out this one, right? At least try to do part A. Don't worry about part B just yet, but try to do part A. And in the next video, I'll go ahead and solve this one. Okay.